All right. We'll waste 5 minutes time. Look at all this editing I got to do.
Yeah, but you can't hate us now.
Yeah, well, it doesn't matter. Doesn't matter. Doesn't matter. All right. When you look at this, if I said specifically, now, here's what's going on. All of this first part is Markley's investment. All the second part was the Collins investment. I want you to look at it and say, there's 8 of them there. How many are indicating that I would make money on the first investment? I can't remember the name of it. Markley or whatever it is. How many out of the 8 would I be making a profit on just the first investment? 4, he says, which would be the 10-10, the 5-5. Not making a profit, not making a profit. Very good. How many out of the 8, if I said that the Collins is making a profit, how many do you see out of 8?
4.
Also 4. The 8, the 8, the 8, and the 8. Very good. If I said, what's the probability that at least you're going to make a profit on the Collins, the second investment, you would identify the 4, add the probabilities of those 4, and you found the probability of making money on the second investment, if that's the question. So you would say 20% plus 16% plus 10% plus 2%. The probability of, if the question says, what's the probability that I'm going to make a profit if I just did the second investment, you would add those 4 and you give it to me. If I said, what's the probability I'm going to make a profit on just the first investment, you guys told me it was the top 4, you would add those top 4s, and you found that probability. What's the probability that I would lose money on the first investment? How many out of the 8 are there? 2 out of the 8. You just add those 2. You get it? You're getting this now. Okay. This could be very easy for you. Let's go. Here we go. We're going to go ahead and make the event M be that we're making money from the first investment. You told me there were 4 out of the 8 that showed making a profit. And we identified them. The 10, the 10, the 5, and the 5 are the 4. We add up those 4. There's a 70% chance of event M happening. Because event M represents the first investment making money. The event C represents the second investment making money. You went and looked at all 8 and you said there was 4 of them where the second investment was making money. So if the question said event C equals Collins, or the second investment, makes a profit, what's the probability event C could take place? You would find the 4 where that one makes profit, you add those together, there's a 48% chance we'll make money on the second investment. All right, this is easy so far. Here we go. If I said, what's the complement, don't forget what event M is, for example. If I said, describe the complement of event M, you got to go and say, okay, event M is the first investment making money, and it was these 4. The complement would be the exact opposite. That's right. It would be any time the first investment would not make money, which would be the other 4. But you don't have to go find the other 4 and add them up. Once you calculated the event, the opposite of that calculation would be the complement, because it's the opposite of the event. So let's go to, real quick, you ready? Markley, the first investment making money, you said there's a 70% chance. What percent chance of the complement? 30. You said Collins, the second one, there's a 48% chance of that event coming true. What's the percent chance of the complement? That's right, you got it. All right, let's go to the next one. Look at, we're flying. The union. Now, no matter right now, if there's anybody daydreaming, they're going to mix up union with intersection. It's a very common mistake on a test. I bring this up because if I can get you past these things that a lot of people do, I've done these tests for a long time, then I'm going to try to get your grade better. Okay, so here's union and intersection. This is where we're at. I can't remember the word I used to use to remember this. I'm already getting mixed up with my mind. Okay. Union, the way to remember it for me was I always put the word or big letters right next to it. An intersection, for me to remember that one, I always put the word and, A-N-D, right next to it. And this is how it jogs my memory. The union means that either event could become true. Event M is the first event making profit. In fact, let me go back to the list so you can really see this. Let me get the 8. How many out of the 8? You ready? The word or. Event M is that the first investment makes profit. And you already pointed out some that did it. If I ask for the union with event C, which is the second event making profit, if it's a union, you only got to look for, out of those 8, any of them where either the first or the second are making a profit. How many meet that criteria out of those 8 where either one or the other are making a profit? 6 out of the 8. Because there's only 2 out of the 8 where neither one's making a profit. This is neither one's making a profit there, and neither one's making a profit there. But the other 6, one or the other. So that's why I use the word or next to union. Jump in.
I understand, like, we're talking about now, this is kind of going back a little, but I don't understand how we decided that which 4 were gains for each company.
Okay, you ready?
Yeah.
The event M was that the first investment's making a profit. Only look at the first investment outcomes out of these 8. See which ones are making profit? Just the top 4. That's how we found it. Event C was the Collins company making profit. Only look at the right-hand numbers because they represent the Collins company if we go back to your slide. And there's only 4 of those where that one's making a profit. So that's how we got those 4.
I was thinking of it as a relationship.
No, not a relationship. They're separate events. But now, how do we identify the intersection? The intersection, the word you want to remember is and, A-N-D, because it goes like this. If I said, what's the intersection between event M and event C? M says the first investment makes money. Event C is the second investment makes money, but the intersection is where M and C both make money. That's right, very few. Now, I can't tell you how much I just emphasized or and end, and someone's going to mix those up. It's just a very common thing. But the intersection means they both, and both of them. The 10-8, the 5-8. There's nowhere else are they both profitable. Only those 2. And if I said, what's the probability of the intersection now? You just got to look at those 2. 10 and 8 is 20%. The 5 and 8 is 16%. What? 36% chance of the intersection of those 2 events.
Do union and intersection always work in pairs like that, where it's 6?
It's always about 2 events, and where both of them are true. Yes, pairs. Always pairs.
So there were 6 that for the union and 2 for the intersection of the 8 total.
Exactly.
Like that.
And if I were asking you what's the probability of the union, you got to add those 6 you discovered. If I asked you the probability of the intersection, you would add those 2 you discovered. Or you could use the formula, which I'm about to show you. You'll be given the probability percentages, just like that. Absolutely. Well, I can't guarantee you whether there's 8 of them or 6 of them. I'm giving you all the probabilities of however many possible outcomes, and then you're being asked questions about this that you got to calculate the probability. Okay? And it's not that hard if you get this logic down. It's not as hard as some people find it. I'm breaking this so easy. I'm hoping you guys would just be able to look at this and go, and just show that you're adding the 20% plus the 8%, whatever you're doing, show the work that you're doing. Don't do it in your head and not put it on paper. Here we go. We did that. We're at union. Here's the union of 2 events. Here's 2 events. What's the probability that Martin Oil is profitable? Event M. And event C, or event C, here's union. Here we identified there were 6 of them. We add all 6 of those together. The probability of a union between these 2 events, that one or the other is profitable, 82%. Intersection, you guys said there was only 2 out of the 6 where they're both making money. I thought it was on the next slide. And so we identified those 2, the 10-8 and the 5-8. We grabbed those 2 probabilities. we add them together, the probability that both the first investment and the second investment are profitable, event M and C are true, 36% chance. So far so good? You ready? Or you could use the addition law. Because there's a chance you may have a problem where you're given the probability of A, you're given the probability of the union, maybe you're given the probability of the intersection, and the question may say, what's the probability of that second event, C? But you don't have the probability of C. You don't have them all. You only have the probability of the first event, that Markley is profitable. You're given the probability of the intersection, you're given the probability of the union, but you're not given the probability that Collins is profitable. You plug in what you do know into this addition law, you can find the answer to any of the others by using algebra. And the example right here, I don't know which one we're not getting. We want to find the probability of the union. We're given the probability of the first event in this case. We're given the probability of the second event. And we're given probability of the intersection. But we don't have all the probabilities to figure out the union. So we'll go ahead and use the information we do have, plug it into that formula, and we know the 70% plus the 48%, and if we subtract the intersection, we'll find the union. So 70 plus 48 minus 36, 82, and if you go back, the calculation for the union was 82% when we knew all the probabilities. I'm giving you an example here where you're not given all the probabilities of each outcome, but you're given enough information that you can find different answers. If I were to say the union's 82%, the intersection is 36, and the probability of Markley event, M event, 70%, you could use algebra to tell me the probability of the Collins event by plugging it in, use algebra. Mutually exclusive, I never test on, almost never, but I do want to make sure you realize it means that the two events have nothing in common, that they don't have any possible outcomes that cross. Now, here's the traditional example I give, if you're no stupid. If you were collecting data from people who are not working right now, and you asked them the question, and then you're collecting, I'm trying to think how to state this, and you're collecting data with the question about what form of transportation do you go to work in? Public transportation, your own car. The two collections would never have the same data because you're collecting data about from those who are not working. And the other data is what form of transportation you take to work. They're not working. So there's no way these two would ever have anything in common because they're not taking any transportation to work because they're not working. Do you get it? They're mutually exclusive of each other. Trust me. That's all you need to know. Don't even study that one if you're studying at all. You ready? Mutually exclusive happens to have the same, is that called the addition law? The addition law, except for the intersection doesn't exist because they have nothing in common. The intersection will always be zero. Don't worry about this. Mutually exclusive will not be on the test. How's that? You just want to make sure you knew what I meant. Now, conditional probability will for sure be on the test. Because this is a big deal. You're going to see a lot of conditional probability questions coming up in the future. If anybody notices that I didn't put a conditional probability study problem on Blackboard, and it could happen, it's unbelievable how I have absolutely no time to think about these things sometimes, bring it to my attention and I'll add another question and make sure it has a conditional probability so you can see it in action. And it basically says, let's call A the Markley and B the Collins. The first had 4 possible outcomes, the second one had 2. This says, if one event is given, the word given means you've been told it's going to happen, that it's true. That's the condition, that you figure out the probability of the other event. Now, let me make sure you understand what I mean. I'm going back, all the way back to the beginning list. If I said, come on, the beginning list, there it is. If I said, given Collins' investment is going to make money. Before I even keep going with that sentence, how many out of 8 is in the given that I just said? 4. There's only 4 out of the 8 where Collins is going to make money. So when you're now doing your conditional probability, you don't even look at the other 4, because it's given that Collins has made money. What's the probability then that Markley will also make money? Now, only look at those 4 and tell me how many out of the 4 that was given did the other thing come true. 2 out of the 4. Let's talk about these. There's this one, that one, and the top one, right? And the 2 out of the 4, where I said, given Collins is going to make money, what's the probability that Markley will also make money? You can only look at those 2. So you got to look at you got to take the probability of the 2, but you're only dividing by the probability of the 4. The other 4 are not part of the equation at all. Now let me get to an example so this makes more sense. But do you see what I was getting? Whatever the given is, the part, you only look at the given options. The other options are out of the picture, like that's your 100% almost, and that's your denominator. So here we go. This one's a little harder for a lot of people, and it took me a little bit to, here we go. Given Markley Oil's profitable, it says, what will be the conditional probability of Collins Mining profitable given that Markley Oil's? Now this is the opposite of what I just asked you. If we were to go back and look at Markley, how many of them out of the 8 was it profitable? 4. The denominator would be just those 4. You add up those 4, we did this already, it was 70% that the M was going to be true, that Markley was going to make money. So we're trying to figure out of just those 4, that 70%, what the probability of Collins becoming profitable. We don't even consider those other 4 that are not part of the given. Even though there's maybe one where Collins is profitable, it's not part of the question. That's where the condition restricts you. You only look at the given.
So all you're doing, instead of using 100,
That's right.
you're just using
Whatever the probability of the given is. Now, a lot of these questions have given as the last part of the question, and that confuses some people. Jump to the given and find the probability of the given and make that your denominator, and then read the whole question. That's how I do it, because I don't want to screw up that part. Given that Markley Oil is profitable, and there's a 70% chance of that happening, there was 4 of them, if we add those 4, it adds to 70%. What's the probability then that Collins will be profitable? Out of just those 4, there were, it would be the intersection of those, where those 2. Matter of fact, I want to go back so you can see the 36%, where it came from. I want to make sure you get it. You ready? We're gonna, this says, get back. There we go. We're only looking at those top 4, because the given is there. The top 4, 20, 28, 38, 48, 58, 60, 70. Those top 4 add up to 70%. Now look at the ones where Collins profitable, they'll only look at those 4. You see 2 of them, correct? The 8 is 20%. This other 8 is 16. Add those 2 is 36%. There's your numerator. Divided by 70% your denominator. The odds, the probability that Collins will be profitable if given Markley's profitable, 36.36 divided by 0.7 is your conditional probability. You don't use the 100, all of them. That's the key. And to only look at the givens only, and don't let temptation drag you down to this one and this one. Because they're not part of the given. Get it? Because that's a very common mistake. Here we go. Is this it right here? No, too much. Here we go. 70% was the denominator, 36% the numerator. If Markley's going to be profitable given, the probability then the other one being profitable is 51%, about 51.5%. Multiplication law. Yeah. We got time? We got time. I want to make sure you guys get this conditional probability. I'm going to try another one. Yeah, let's try the other one. Let's go the other way. All right. You ready? Let me get a pen. Given Collins is going to be profitable, what's the probability of event M becoming true, which is Markley profitable? My denominator, I want that first. Help me out. What numbers? Give me the numbers. 20 plus 16, that's 36, plus 10, that's 46, plus 2. What? 48. So this one is 0.48. Now don't even look at the other 4. because the condition is Collins is profitable. Looking at only those 4, how many out of those 4 is event M also true? 2 of them, which happen to be the top one, which is the 20, and the third one, which is 16. Is that right? Which is, so 0.36 divided by 0.48, you just found the conditional probability of given. Now let me show you how this is written. Markley is like our first event, the A. Collins is our second event, the B. Now just so you can understand these letters, I'm going to, let me get here. Okay. This 48%, I was asking about the Collins first, correct? That was the given. So, the condition is always the second letter. The given is the second letter. The first letter is what you're asking to find the probability of, given the second letter. So if this is written like this, it'd be, the words would be the same, given B, that Collins is profitable, what's the probability of event A, in our case event M, that Markley's profitable. You got to know to only look at the probabilities of the given as your denominator.
So you may be given a problem like this.
Possibly.
Instead of a
I don't think so.
Okay.
But I do need to know, you need to know, because I believe there were homework on this chapter. There are problems that are given it to you like this. You got to know the second letter represents what's given. So if I were using the symbol only, you would either have calculate, hang on a minute, that, or it'd be calculate, see how I did it, M line C or C line M. This one, Collins is the given. This one, Markley's the given. That's the one I wanted to point out that you get. Especially if you start doing some practice problems. I think some of the things I'm posting for you to study might have this, and I want to make sure you understood it. All right, conditional probability, we got it. Multiplication law. This is one of those good ones, again, where if you only give them part of the information, you can always find the other. Multiplication law only applies though the conditional probabilities are involved. So it's saying, hey, you know this conditional probability right here? What's the given here, A or B? B is the given. You can either